Okay, so we're about more than halfway through this unit. We did SOHCAHTOA, we solved for missing sides, we did some word problems with angle of elevation and angle of depression, and then we did some double trig ratio word problems, so that's when you had to do your trig or SOHCAHTOA twice, and then we just solved law of sides. So now what if instead of solving for missing sides, we're solving for missing angles? So the first four problems are your warm-up for today, so I want you to take a second and try them. We're going in reverse. So usually in problem one, I would say how many people were in Buffalo in 1960, and then you would look it up. Well, here I'm giving you the population. I want you to find the year. So we're going backwards in all of these. So take a minute and try all those, and then pause the video and come back and get your mindset into thinking about reversing. So after you're done, what we're going to do is we're going to start looking and solving for missing angles here. So I know a triangle adds up to 180. However, I only have one angle in this triangle, and that's that right angle. So it says determine the measure of f to the nearest degree. So I want to know what this angle is. Well, like anything in this unit, what we have to do is we have to label our triangle. So if I'm talking about angle F, that means that any side opposite angle F would be my opposite side. Remember, hypotenuse is always across from this right angle, and then your adjacent side would be next to. So still using SOHCAHTOA, we're just going to plug it differently into our calculator this time. So I'm going to write out my SOHCAHTOA to help me see what trig function I have to use. If I look, I have a length on my adjacent side and a length on my hypotenuse side, so I'm going to put a star under any H or J. So here's an H, here's an H, excuse me, A. So here's an A and here's an A. So I would be using cosine. Formula for cosine was cosine of your angle equals adjacent over hypotenuse. So let's fill in the blanks. Well, I don't know what my angle is, so I'm going to put an X where my angle is. The adjacent side is 4.9 and the hypotenuse side is 8.3. So let me tell you something. Cosine and X, they don't like to be separated, so I can't divide by cosine. I can't just multiply by cosine. Cosine and X are like peanut butter and jelly, butter and popcorn, cookies and ice cream. Like, they just need to go together. So one thing we do to separate them is called the inverse, okay? So when you have this and you're solving for X, we're going to take an inverse. So it's something special you have to remember. What that does is it gets X alone. So it's going to be X equals the inverse of cosine. The inverse is that -1 of 4.9 over 8.3. Now you're probably saying, Ms. Hoke, I don't know what that is. So let's jump over to our calculator. So here's my calculator. If you notice right above your cosine function, you'll see it in blue. It says cosine -1. Well, that's just what we wrote here, cosine -1. So I'm going to use that. Now in order to do that, I can't just hit cosine. Cosine doesn't give me that -1. So I have to make sure that when I want that -1, I'm going to hit second cosine. If I do that, then I get that -1 that I want. So when I do that, I can find the inverse. So I do 4.9 divided by 8.3. When I do that, I hit enter. Notice how I got 0.939. Now, in your calculator, you might be saying, I did not get that. I did something wrong. But let's see. Remember, we always need to be in degree mode. So if I hit mode, notice how I'm in radian. So it gave me a decimal. So I'm going to change it so I'm in degree mode. I'm going to hit second quit. I'm going to type in this equation again. So second cosine gives me that -1 of 4.9 divided by 8.3. Now I get my correct answer. So we get 53.8 8, but it wants it to the nearest degree, so that would give me 54 degrees. So I have my x equals 54 degrees. Remember, x was just the measure of angle F. So make sure you write the measure of angle F. And that's my answer. So a little bit different than solving for missing sides. Instead, the only thing really different is that you're hitting second before you hit your trig function. So same thing, we still do SOHCAHTOA, it's just that now we're hitting second before we plug it into our calculator. So let's try another example. It says the altitude of Big Peak is 150 feet more than Little Peak. If the horizontal distance between the peaks is 985 feet, what is the angle of elevation? So remember, the angle of elevation was when the dog had eye level and then it looked up. So the horizontal distance from here to here is 985 feet. Then it says that this peak is about 150 feet taller. Now, angle of elevation was this part right here. So what you have to do is, now we're solving for this bottom angle. So label your sides. What side's your hypotenuse? What side is your opposite? What side is your adjacent? So if you notice, we have side lengths on my adjacent side and my opposite side. So I'm going to write my SOHCAHTOA and figure out what trig function I am going to use. So if I have adjacent, that's my A. If I have opposite, that's my O. Looks like my tangent is the one I'm using. So we're going to set it up. Tan of your angle equals opposite over adjacent. Now I'm going to put x where my angle is, so I know that's what I'm solving for. So it's going to be tan x equals 150 over 985. So again, I have a special case here. I have tan x. Well, just like any function, tan doesn't like to be separated from x unless it's a special way. So, special way, we do the inverse, remember. So that would be your x equals tan with that -1, and then 150 over 985. So I'm going to come over to my calculator again, and then I'm going to do second tan 150 divided by 985. Close that parentheses and hit enter, and then I get that x is about 8.6587 degrees. So if I come back and I look, it says, doesn't say round or anything, so we'll just leave it like that. So that means that bottom angle is about 9 degrees if we're rounding to the nearest degree. Okay, let's try one more together. So determine the measure of angle T to the nearest degree. So angle T is talking about this top angle. So right now I want you to label your sides depending on that top angle. So always across from the right angle is your hypotenuse. Across from angle T is opposite, and then next to it is adjacent. So this time they give you 3 side lengths, which means you can use any trig function you want. So if they ever give you 3 side lengths, you can use any. So in example A, we use cosine. Example B, we use tangent. So here I'm going to use sine, just to change it up. So sine of my angle equals opposite over hypotenuse. It doesn't matter what trig function you use, you're still going to get the same answer, even if you choose not to use sine. So I'm going to call angle T my x. Sine x equals 10.75 over 11.86. So again, here's the special case where I have sine and x, so I have to do that special thing where it's the inverse. So it's going to be the inverse of sine is 10.75 over 11.86. So I come over to my calculator and I do second sine, remember? Gives me that inverse. 10.75 divided by 11.86. I hit enter, and that means that angle T is about, let's round to the nearest degree, 65 degrees. So the measure of angle T is 65 degrees. Now, let's say if T is 65, how would you solve for R then? Remember that angle T and angle R have to add up to 90 because there's a right angle in your triangle. So if I did 90 minus 65, that means angle R is 25 degrees. So that's just an addition bonus. So during this whole rest of the sheet, I want you to remember that when you have your x next to one of your trig functions, you have to remember to hit second in your calculator. If you don't, you're not going to get the right answer. So good luck with the rest of the sheet.